presenting Pups Analyze. Thank you.
Thanks. Thanks for being here. Hi, my name's Mark. I work at Datadog. And today I'll be sharing a case study on how we've recently adopted Apache Iceberg and showcase some of our initial use cases that we shipped to production. So I'll start with a short intro about Datadog and kind of where we were before Iceberg, and then we'll walk through what our implementation journey looked like. And after that, we'll get into some of the use cases and some things on our roadmap. So a little bit about me. My name's Marc Cenac. You can remember my last name because it sounds like the middle of a three-way handshake, Cenac. And then I've been in the big data world for over a decade now. And I've held various roles doing data engineering, so Spark jobs and ML pipelines and things like that. So I guess it's called AI now. So I've dabbled in that. And I joined Datadog about 4 years ago. And I was working on our internal Jupyter Notebooks tooling and some Spark infrastructure. And the team I was working on at that time was building a custom metastore. And that's kind of how I was drawn into Iceberg in the first place. But we'll get into that later. So first off, who's heard of Datadog before? Just kind of curious. All right. And who's using it currently? All right, cool. So about half. Cool. So Datadog is an observability platform. So it's a SaaS for monitoring your software applications and all the things related to that. So initially, it started in 2010 as an infrastructure monitoring product. So this is mainly metrics. And it would collect metrics and allow you to visualize them and then send alerts on things that in your infrastructure, like if your disk utilization on your database server was filling up, it would send you an alert. Maybe it would send you a page. And then so for the initial years at Datadog, they were scaling this metric system. And then after that, they added APM, which is like distributed tracing. And then they added logs into the product as well. And so at that point, they were calling, the three pillars of observability were metrics, traces, and logs. But since then, there's been many more kind of products added onto the stack. So there's many new things, and I'm lucky I get to use it all. We dog food at Datadog, of course. So we're using all of our own products, which is good. And as you can imagine, with all this, we're ingesting a lot more data, and we're storing a lot more data. So it's over 100 trillion events a day. It's just kind of a lot of data ingested. And the majority of this is telemetry data, right? So it's coming in from billions of containers and logs and your cloud services, your browser, all these things. So it's all being ingested. Now, you can tell this is not a slide from the marketing deck. And this is kind of the high-level overview of the Datadog architecture. So very high level. So at the top end, we've got the agent, the Datadog agent. So this is something that's running on your infrastructure. So maybe like your operating system or Kubernetes cluster. Or maybe this is like a jar that you're adding to your Java class path, right? And it can auto-instrument your code and send all of this information into the intake. And then we have lots of crawlers and integrations with other systems like your cloud provider, which can send metrics or events kind of to Datadog's APIs. And at the highest level, we're buffering all of this into Kafka, and then it gets processed and persisted in various different data storage systems. So like the metrics data is going into a metric system. The events like logs are going into a system called Husky, which is a great dog name. I've got a lot of dog puns at Datadog. Also, there's a good series of blog posts online about Husky, so if you want to check it out. It has some similar characteristics to Iceberg, so you'll see that, but it's optimized for like telemetry and kind of unstructured data coming in. So we have these systems like in-house systems for metrics and for events, but we also have a lot of other data storage systems that you've heard of, like we use a lot of Postgres, Cassandra, Elasticsearch, MongoDB. Like we have a lot of different data stores. And so as the data ages, so it comes in, and it's going through different storage tiers. And this is so it can be queried efficiently and cost effectively for the type of query workload that it is. So for example, the alerts and the monitors, like this is querying the most recent data because it's going to be sending an alert, right? So it's like a rolling window on the most recent data. It needs to be really fast. This is a custom kind of in-house system, and we're reading this data out of memory. But then if you're wanting to query like, beyond the last day or so, we're gonna be storing this in a mix of SSDs and object storage because it's less expensive than memory, obviously. And then even within object storage, we can have like intelligent tiering, and we can also like write out data to the customer's buckets and then rehydrate it if we need to do it that way. And so we have several different flavors of ETL that extract the data from these telemetry systems and then load it into cheaper, more durable storage systems that are better suited for other use cases. So sometimes this ETL will look like, maybe it's a streaming job, right? So it could be reading from Kafka and then writing to a custom file format, or maybe it's writing Parquet files. Or it could be a Spark job, doing aggregations. So for example, the metrics data is coming in, maybe we have second resolution. We want to roll that up every 5 minutes. And then whenever that's done, we'll roll it up every hour. And those can get, and then every day and so on. And that's stored in a variety of different ways. So we have custom file formats for serving out metrics data at low latency. And then we also use Parquet, which is great for doing analytics. And doing this type of ETL is challenging because the telemetry systems are optimized for this low latency use case that we have. And so they're not great for large scale analytic workloads. And so we use a lot of Parquet for that. And we also need to be careful with our ETL processes that we don't impact the production systems. So we move them into different storage systems that won't affect the production systems. And that's the kind of data processing that my team works on. It's within our scope, and we're called the Analytics Data Platform. And we're responsible for running data processing infrastructure for analytics, and we serve a lot of the data analysis use cases at the company. So our teams run Spark and Flink on Kubernetes, and we have custom tooling for that and for running batch jobs. And we support multiple teams at the company. And we're running nearly everything on Kubernetes at Datadog. And initially, we're using services like EMR. But we're large enough that it makes sense for us to do this on our own. And also, because we're running on multiple clouds, having Kubernetes as like the deployment target makes it a standard interface for us to deploy all these things. We also we handle a lot of the traditional business intelligence use cases. So thousands of people at Datadog are using our platform to do self-service analytics. So maybe they're building dashboards to track product usage or revenue. We also have this cool logo because we used to be called Data and Analytics, and we had DNA. It was shortened to DNA, so we have this cool logo. And this is what our current offering looks like. Let's see, you can see that. So we've got several systems to empower people to do analytics. So we support data analysts and many other non-engineering people who use our BI tool, which is Metabase. We support data scientists. We have a managed Jupyter notebook service and some other tools. And then data engineers are using a variety of all these tools to kind of do the processing to build what they need. And we have in-house systems like the Analytics Hub. It's like our data discovery portal. We use Snowflake as a data warehouse. So we have a lot of automation around access control here. So this might be requesting access to a specific data set or a view or some schemas. And we have automation like when people join the company, we'll add users and remove them when they leave. But as you can see, Iceberg is starting to play a more important role here, and we're really building out a Lakehouse architecture. But let's step back and see how we got here. So before Iceberg, I'd say we had a mixture of a data warehouse with Snowflake and a data lake, which was a bunch of Parquet files everywhere. And I would say it was more like a data swamp. This is what a data swamp looks like, according to Dali. And I live in Louisiana, so I know a swamp when I see one. And the main characteristic is you just have Parquet files everywhere. So it's not really easy to work with. So maybe you need to find the data set by talking to a team and seeing how they build their paths to their data if you want to read it. Or I guess we just had paths everywhere, and the point was it wasn't really accessible. So that's what the data swamp was. So we had path building code and Python jobs, and each team had their own way of like writing partitioning. And then oftentimes these Python jobs would dynamically generate paths, and it would be passed to a Spark job. So the Spark would read in some input paths, do some processing, and then write out to some output path. And if you wanted to read this data, then you'd have to launch a notebook and paste your path in there. And this is kind of how it was for a while. And to kind of help us solve some of the challenge, because this got really messy. So to organize it a little bit more, we built an internal metastore called Census. And the main idea there was that we would build on a higher level abstraction than paths. And this could help us reimagine how our pipelines were built. So whenever you're relying on paths, the scheduler is looking for that path to say, do I need to launch a task to create the data at that path? And I think this approach made it so that we weren't really thinking about higher level concepts like the data set or the table, and we were mainly thinking about the tasks and scheduling that. So Census was designed to track a data set lineage at the partition level. And once we captured all of this metadata, then we could do things like dynamically rerun a downstream pipeline if the upstream data had some quality issues. Census was also tracking a lot of other metadata that we were using for our data discovery. So at a high level, it started as a REST API written in Go, and it would store the data in Postgres. And then we sort of added an async intake queue. And eventually, downstream, we were doing CDC to populate our data discovery hub and do some kind of event-driven scheduling. And Census improved the situation because we were now able to work with like data sets and partitions, and we had the schema info in there. But it was still tightly coupled to the scheduler, and the paths never really went away. And also, we didn't have ACID transactions really because we were relying on the scheduler's locking mechanism to ensure that multiple jobs weren't running at the same time. And this can be kind of error prone. So it started becoming apparent, at least to me, that we were building something similar to Iceberg, but it wasn't quite the user experience of a SQL table, and it wasn't integrated with the other query engines. So this is like a random comment that I pulled from a Jira ticket that I was working on, and I was like, we're building something that looks like a Hive, or because at the high level, we were querying our metastore and we were getting back some paths, and then we were passing that to the query engine. So we had some partition pruning, but it was very primitive. And I'm not sure exactly why we didn't have Hive or never really used it, but this is before my time. But I'm guessing it's because we didn't have HDFS. They started out just writing to S3, and they were using RDDs and just kind of using Spark for parallel computing at the beginning. But regardless, I started becoming convinced that we needed something like a table format. So we started experimenting with Iceberg, and we liked what we found. And I think most people here probably already know some of the technical benefits of Iceberg, so your schema evolution and hidden partitioning. We like all that too. But for us, I think we really liked that Iceberg was vendor neutral. So because we're running on multiple cloud providers, we don't want to use something that's just provided by one vendor. And we didn't want our data siloed at any one spot. And second, we liked that Iceberg is Apache open source. So both the license and the governance model. We use a lot of Apache open source projects, and we think it's a good way to do open source. And also the community seemed really strong. So it had committers from multiple companies, and they were very helpful in getting us started and answering questions. So it seemed like it had momentum at the time. And we also liked that we could get this query engine flexibility. So we already had systems that were able to read and write Iceberg because they were reading and writing Parquet. And I think this was really powerful for us because these other internal systems, like the telemetry systems, they're going through specific like reader APIs. So you never go to the file format directly to read it. And we realized that having this ability to have multiple query engines access the data directly was very powerful. So other reasons why it was appealing, like we already had Parquet files everywhere. So it was ubiquitous in our analytics stack. It's a great format for doing analytics. And then we also had teams who were running Trino, Spark, Flink. We were using Snowflake, and Iceberg could be used by all of these systems. And finally, having a SQL table interface versus paths is really helpful. And I think this democratizes the data. So they have a lot of people who can write SQL, but maybe aren't as comfortable spinning up a Jupyter notebook, maybe writing some Scala. So the SQL table was really appealing. And the Iceberg REST catalog, at the time, we were seeing that's where the community was heading. And it was appealing because, it's language agnostic, and we could hide a lot of the complexity behind the HTTP API. So maybe if we were doing something like scaling or load shedding, access control was another thing that we thought was really interesting. So the Iceberg REST catalog almost is like an inversion of control of the auth system. You can kind of ask the catalog, and the catalog can make that decision rather than configuring your engine. So we liked that. We thought it was good, and we decided we'll just build an Iceberg REST catalog on top of our Metastore. And at the time, there weren't many open source or any open source options to choose from. So it seemed reasonable for us to try this out and build on top of our existing infrastructure. But we started running into some issues. So initially, we were taking the open API spec, and we were generating the code in Go. So our Metastore was written in Go, and we were trying to generate the stubs from the open API, and it wasn't always usable. So in my view, open API is great for documentation, but it's not good for generating stubs, especially compared to something like gRPC for Go. And we noticed the spec the spec that's in like the YAML, the open API, doesn't always match exactly what's in the Java implementation. So there were some quirks there, and we were able to kind of push some fixes to make sure it was all up to date. So we continued to kind of port the functionality from the Java implementation into Go. And this was more tedious than we expected. You have to go and read the Java implementation and then go implement it in Go. And there's a lot of things that are in the implementation that maybe aren't really in the spec. So you need to go discover these quirks by reading the source code. And the Java idioms don't translate well to Go always, so that was another challenge. But we got something working after a little bit of time, and we started to experiment with Spark. So Spark started reading and writing these tables, and it seemed to be working fine. So it was our initial proof of concept was able to do this. Let's see, oops, that looks weird. This is there's a commit report, so this was sent to our back end, and you could see it. So this is integrated into our system. We were thinking, hey, we can use this for like event-driven workflows. Whenever a table's updated, we could send this into our system and do something based on that. But then we started to run into some compatibility issues. So we were writing the tables in Spark. We wanted to read them from Snowflake, but we had this bug, so we couldn't read it. We couldn't figure out why, so we submitted a support ticket, and we were like, it must be something on Snowflake's side because Spark can read it just fine. So we had some back and forth with their support, and then we discovered it was actually a quirk in our implementation. And the root cause was we weren't doing something that was in the Java implementation. So there's a quirk where the REST catalog client will send over field IDs starting with 0, and the catalog's supposed to increment that by 1 before it stores out the metadata. And that's why Snowflake couldn't read this. So I wasn't sure if this was a bug. I started kind of asking the community, and they were able to answer this and say, no, the catalog needs to do this. And why? Because it's in the Java spec. If you want compatibility, you just kind of have to make this work. And I feel it's a rite of passage to have Russell or Edward answer one of your questions and help you learn about Iceberg. So anyway, we fixed this issue, but then we ran into another one. And this time we learned, well, you can't use write metadata path as a table property to write the metadata into a different bucket than the data. But this works for Spark, but not for Snowflake. And this threw a wrench in our plans because we were planning to keep all of the buckets in, all of the metadata in one bucket that the catalog could own, and then support other teams who had data in buckets that maybe they didn't want to give us access to for compliance reasons. And we wanted to maintain this permissions boundary, so it caused some extra work because we had to kind of duplicate the metadata onto the other buckets. But we were able to make this work. But then we had even more kind of bugs and feature requests coming in. So we started integrating Trino, and there's some quirks there as well. And at this point, we were saying, okay, well, we need to do some other work as well. We can't spend all of our time just working on the catalog. We needed to get around to other things like maintenance and access control. So as a tactical move, we decided that we would just abandon our Go implementation. And what we did is we switched to the JDBC catalog backend, but behind the REST API, right? So we already had clients connected to our REST API, but by swapping out what's behind the REST API to use JDBC instead of our custom implementation, this would give us the Java implementation of table operations, which is stable, and it would allow all of the catalog clients to not even notice. So this is an advantage of using REST catalog. In my view, is you can swap out the backend and the clients won't know. So this is great. So we ended up with something that looked like this. We were Iceberg REST catalog interface, but kind of behind the scenes, we were using JDBC catalog. So it's just a simple reverse proxy. We also, implemented the metrics endpoint, and we're sending the metrics into Datadog. So that's kind of the setup that we had, and it worked well. But we needed to do some things to actually make this work in our infrastructure. So one thing was we have a specific way to handle database migrations. And by default, the JDBC catalog tries to create the tables, or initially it did. So you can disable this now. But this was like a requirement for us to not have the application user have credentials to modify the schemas. We also needed to implement a JDBC driver to integrate with our custom Postgres infrastructure. So we have kind of a database connection pool implementation that requires doing authentication in a certain way. And instead of trying to write our own implementation, we just said, oh, well, if we write a driver, we can push it all behind the driver interface. So that worked, and we got it working on our infrastructure. And while we were doing this, other teams at the company started wanting to use the JDBC catalog with their own Postgres instances. And one of the main reasons, I think, is because we weren't really production ready with our REST catalog, and we didn't have enough people to support it for some of the product use cases. But the JDBC catalog worked for them, and they're still using it in production. So I'm assuming they'll eventually want to migrate to the REST catalog, and it won't be a big deal for us to migrate this later on. So after we got the catalog stabilized, then the next thing we needed to do was build out this non-catalog infrastructure. And primarily, this is automated table maintenance for all the tables in the catalog. And I think whenever people first encounter Iceberg, they just sort of expect auto vacuum and auto analyze, or maybe they don't even realize that they need this. And you don't want to force people to learn about Iceberg maintenance just to use the Iceberg tables. So we wanted to build some tooling to make this automated for people. So we built some Spark jobs to expire the snapshots, delete orphan files. Also, I put a warning here because you need to make sure that your table locations don't overlap. So if they do overlap, you'll accidentally delete files from another table. So we discovered this in staging, thankfully. And then we had the other kind of optimizations, so rewriting data files and manifests. And then we needed to integrate with the rest of our infrastructure. So initially, we didn't do credentials vending because we have a specific way of handling credentials in our runtime infra So we've got, we use the instance metadata APIs. So this is how our pods in our Kubernetes clusters are reaching out via the instance metadata service to get their credentials. And this is a way that we can standardize it. And it goes through Vault. So Vault is the thing that is talking and calling the STS APIs. We also have some caching in there because there's some limits. But mainly this was done to standardize how we do it, because we have many different services, and we didn't want everyone running their own clients to connect to the STS services. So we standardized this. So that's one of the reasons we didn't do credentials vending initially. But I'm thinking we'll probably get back to that soon. Finally, we put a gateway out in front. So this helps us do things like MTLS, and it's going to prepare us for future use cases where we might want to do routing behind this gateway. So I don't know. I think this is a good setup that we have right now. We're going to look at other REST catalog implementations in the future because they've matured in the last, even 6 months. And I think this is something we'll revisit later on. And we can swap out the backend and no one's going to really know because we're using the REST catalog. So a couple lessons learned here. The Java implementation, it is the reference implementation. So it can be used as a reference. You have to read the source here. Implementing in another language is a lot of work. Next, the JDBC catalog is an easy way to get started with the basics. So if you want a basic catalog functionality, JDBC catalog is good. It works. It doesn't have all the benefits of an Iceberg REST catalog, but it's something you can use to get started with. And then finally, you need more than the catalog to make it work. So the catalog is going to become unusable if you don't expire the snapshots, and you need to have something in place to handle the table maintenance. Otherwise, you'll have metadata sprawl and your queries will get really slow. You don't want that. And then finally, the other lesson learned is the query engines are going to have different levels of support for the Iceberg functionality. So even like one with Snowflake is you can't use equality deletes, right? So you can write it in Spark, but then you can't query that table in Snowflake. In Trino, you can't do write, audit, publish, right? Which is a great pattern, but we can't do this from Trino. Trino's a little different with its SQL grammar. So you can't do some of the branching syntax, or maybe it's going to be different. And you can only set certain table properties, right? So it's a limited subset. And there's going to be many quirks like this as you interact with multiple engines. All right, so next I want to talk about some initial production use cases that we've shipped. So I'm going to start with the revenue data engineering team, and they were one of the trailblazers of Iceberg with us. They use a lot of our internal analytics tooling, and yeah, so they're responsible for generating. They run Spark jobs, Flink applications, things like that, and they're responsible for generating metering data sets for all the products, and so this is important because it helps us bill the customers. We bill them by usage, so. We worked with them to kind of build out a set of unified data sets as Iceberg tables. And initially what they were doing is they were producing a lot of different usage data sets, and these were expensive and maybe built on some legacy systems that they wanted to deprecate. So the idea was that they could instead build this kind of foundational table that could be used for analytics, for product functionality, and for billing. And they also do a lot of work around data quality and freshness because these data sets are used to make business decisions and bill the customers. So it's important that these data sets are accurate and on time. So they use Datadog actually to track if their data sets meet certain freshness criteria, and if not, they'll get alerted. And then they have some pretty dashboards that they made to help visualize when the data sets might be late or not fresh. And then they're surfacing this info in our analytics hub so people can find out about the data set, how to query it. And they're really one of the teams that's doing producing data as a product, I would say. And so it was great to partner with them to show off how Iceberg could be used in the rest of our ecosystem. We also collaborated collaborated with them because they were one of these initial use cases, so they had some needs that we thought would be shared among other teams. So we collaborated with them on a table state controller, and this is kind of like a schema migration tool. And so we wanted to be able to not change the schemas in production kind of ad hoc, but have a PR and kind of go through some process where we're auditing the schema changes before they get rolled out to production. So the other thing that we did is a Snowflake syncer. So we've got some utilities to push the updates to Snowflake so we can publish it whenever we think it's ready for consumption. So maybe we are only publishing the data after certain data quality checks have passed. Another thing we did was the kind of table copying. So this is helpful for a lot of different use cases. So for data locality, we don't have egress costs if we copy the table to another data center. And you can also do things like experiment with the tables. So maybe you want to experiment with compaction or rewriting it. Maybe it's good to have a separate copy of the table if it's not too large. Another team that's been adopting Iceberg in production is our analytics research team. So this team builds research reports like the state of serverless or the state of cloud security, and they publish this on our website. And to make these reports, they need to join across multiple different data sources over like a long period of time for many different customers because they're looking for things like trends, right? And this kind of type of large-scale batch workload isn't great for our telemetry systems because those are optimized for these low latency type queries. And then it's only pulling a certain type of data. So if you want to look over the past year or something, maybe it's not a good fit. So this team will do some ETL from the upstream data sources, kind of on the left. They do some processing in Spark. Then they're writing this out to Parquet as S3. And then they'll copy a subset of this into Snowflake and maybe do some more transformation. So maybe that's ELT. But it's kind of an ETL pipeline. But they're duplicating it right now because they're staging the data in Parquet, and then they'll load some into Snowflake. But what we can do here now is just write to an Iceberg table, and then once it's there, we get these benefits of being able to query it from multiple engines. This team's also experimenting with like tagging and schema evolution because they're going to do the same reports every year. So they might want to reuse a data set produced from a previous year. All right, and this next one is called XPQ. We call it cross-product query. So this is another place we're seeing Iceberg in production, and it's when we want to join across these different systems, right? So we have a metric system, we've got an event system, we have Iceberg, we have some other systems, and then we have a setup where we can query this with a custom type of query engine. So at the top here, we've got a service called Retriever, which is a great name for this service, and it'll take in a SQL query, and it's like a gateway into this system that can do multiple joins. And it's kind of a deconstructed database, as Julian Ledem would talk about. And the idea is like you can take multiple parts and build your own query system. So kind of at the top, we've got Calcite for the query planning and optimization. And then we're passing around the actual plans as substrate, right? So once this gets down into the execution layer, we can route it based on like how big we think that this might be. So if it can do the single node executor, we'll go to Data Fusion. If not, it'll go into Trino. And now that we have all these things like connected into this system and we can do joins across them, it becomes really easy for us to say something like create an Iceberg table as select from this system and join it with this system, and then we can write that as an Iceberg table. And so this gives us another way to do sort of ETL, where we can kind of sample data from the live systems and build out a historical layer with Iceberg. And this is going to be better for those larger scale analytical use cases. So another flavor of this is just materializing results. So we might want to pre-join the data. Maybe it's quicker to serve it straight from Iceberg than doing the join kind of live at runtime. And then we can take advantage of top-N optimizations. So the initial query will maybe only get the first so many rows, and then we can materialize the next pages as Iceberg. And we're doing this right now with a product called Sheets, which is a spreadsheet interface into your Datadog data. So if you want to join or do pivot tables, something like that, you can do this, and it's in the back end. It's powered by this cross-product query system. So roadmap things. What's next? We've got a lot of work next in this year. We're deploying to a new data center, and then we've got lots of Iceberg-specific things that we want to do. So lifecycle maintenance is something lots of teams are going to need, and we want to make this easier for them so they don't have to do it themselves. And this is, data expiration pipelines and maybe temp table cleanup, things like that. Soft deletes is something I want for just table protection or data protection. I think sometimes tables will get deleted or dropped by accident, and it's good to maybe push this into the catalog where we'll remove it from the catalog, but maybe we'll schedule the deletion a little bit later. And then intelligent tiering, and this can kind of save us money for the tables that maybe aren't going to be queried, or the parts of the tables that won't be queried. We also have a lot of new clients that are coming online, so we're seeing many different use cases for Kafka Connect. So this might be doing CDC from Postgres, or maybe it is dumping something from that's already on a Kafka topic, and we want to dump that somewhere, and then do some more ETL and make this more available for analytics. So a lot of times what's on Kafka is nested, and it's not going to be really good for querying. So we have all of our other tools to be able to kind of like explode out the columns and unnest it, things like that. Also, we want to build some finer-grained access controls. So we're going to be looking at credential vending even more and starting to roll this out. And ultimately, I want to get to something where we have like a grant and revoke, but maybe this requires going into the query engine. And finally, we got lots of optimizations that we can do for queries. So definitely looking forward to the variant type, because we have a lot of data that's filtered by tags, and we think maybe tags is going to be a good thing to stuff in the variant type instead of maybe exploding out the schema, because we have a lot of tags. Puffin files, this will help the planner out. We need to start writing this more. And Alexio is another thing that we might be putting in here to save money on cloud costs and lower the latency. So Alexio is this piece that can go in between object storage and the services. So you can kind of cache this data on SSDs, and you can reduce your latency this way. So we're already sort of using some of this within Trino. So Alexio clients can cache the data on the Trino nodes, but having a standalone cluster would make this better because multiple things could use it. All right, and I just want to conclude by saying, I was showcasing the work of many teams at Datadog, and they're starting to see the value of Iceberg. There's many things that I wasn't able to talk about here, but we're still in our early stages of Iceberg. So if you want to help build some of this stuff, talk to me afterwards. My team's hiring, so are some of the other ones. So with that, thanks for listening.
Yeah, we do have some time for questions. 5 minutes.
I have a mic for you.
I'm curious about the choice to adopt Java basically as the language here.
Yep.
I understand how a company that's involved, in another programming language is going to default to this first, but you solve your immediate problems by adopting the standard implementation. Was there a lot of overhead to bringing this new technology in the stack?
You mean to bring in Go or to
bring in Java?
Oh, no. It's fine. I think the team, it's very bottoms up. Like whatever you want to bring in, it's probably fine. If it's Rust, maybe they'll question it a little bit, but I think we are starting to see a lot more Rust. And at the time, I think the Iceberg Go library wasn't as mature, but it's gained a lot, even in the past like month or so. So I'm very excited about this. I think that we will be maybe looking at this more into the future now that you can you have more, the feature parity is caught up.
And then the 5 minutes.
I was curious about your query router and your XPQ.
Yep.
How do you judge which engine would be better? I know Presto has like a history-based cost optimizer. Do you use something similar, or?
Not so. Right now, this is very primitive. So the Iceberg stuff will only work in Trino right now. So that's it's going there. But this is being worked on right now. So we don't have all of that worked out yet.
Thanks.
Hi, have you looked into Polaris as a catalog choice?
Yes, absolutely. So we did an evaluation when it first came out, and that's around the time that we were about to do this switch, and we thought maybe it's just not ready yet. Maybe we'll give it a couple of, it had just come out, and I think we were thinking it's a little bit risky. We don't want to be the first adopter. Maybe we'll let see how things settle. Another one we're looking at is Lakekeeper. That one is written in Rust. It's got some really good auth kind of controls. So I think we'll do a catalog evaluation later on in the year, and it's going to be even more mature by then. So.
Some of the more platform-oriented stuff that you do there, what was missing from me was answer disaster recovery process. And specifically, I'm interested in things like if the Iceberg metadata gets corrupted, have you run into that problem as well with understanding?
Yeah. So the question was about like disaster recovery. I'd say like right now there's a couple things that we can do. So we have versioning on the object storage, so we can kind of do an undo because it's all the object stores have the ability to have some kind of soft delete and undo it. So we have some operations for that, but there's some things like there's already something in the S3 file IO that will allow you to instead of having to do a manual operation, you can do it from the file IO. But it's not ready yet in GCS or Azure. So, but once that's there, we might use that instead to kind of undo an accidental delete.
What is the use case of rewriting manifest files?
Just for like, you don't want to have too many of them. So it's kind of like the small files problem.
Oh, okay. So, but when you expire the snapshots, like, wouldn't it like remove those older manifest files also, or?
Yes, I mean if they're belonging to that snapshot.
Okay, but you might want to independently like.
Yeah, I mean you don't have to. I think it's optional. We just put it in our job. I think.
Okay, I see.
It's as part of the cleanup.
Okay,
I think
thanks.
Ryan this morning highlighted in the metadata trouble that he was highlighting for 2-minute manifest files. So this is a part of it.
Thanks for the talk. So I heard that you mentioned the Snowflake Thinker. So I'm interested because we want to do some things. So I'm curious, how do we sync that to Snowflake?
Yeah, there's different ways to do it. So initially we set this up before they have other integrations now. So you can actually set up Snowflake to reach into your REST catalog if you want. We just never set this up. So we had a system that was like a push based, and you call their metadata or you call their API and kind of refresh the metadata to give it the latest state. And we kind of like the push based approach because it gives us a little bit more control. It's a little bit more work, but I don't know, it's working for us right now. So we didn't see the need to set up kind of authentication from Snowflake into our internal infrastructure. So a push-based approach is maybe.
So is it push the metadata or the actual?
We just push it's like a shoulder tap to update Snowflake's catalog.
Okay.
So the Snowflake will just have the latest metadata in its catalog, and you can refresh that with a API
so
call.
do we have multiple catalog in different places? Snowflake have maintained ones and.
Yeah, so Snowflake you could think of it like, as a read replica or something.
Okay.
Cool.
All right, guys, we are at the
Thank
time
you.
to